Thanks very much, everybody. Try and figure out the clicker here. Just want to acknowledge quickly my co-authors, Emily Stahl and Albany Douglas with the City of Guelph, as well as Ashok Shah and Emmanuel Arnaud from the University of Guelph, who've been very much involved with the update of the model that I'll be discussing today. Also a large list of folks here that have been very much involved with the development of this model. First and foremost, the folks at Montrose Environmental, who have been, actually the ones doing the modeling and the calibration and all of the hard work building this model. Dave Van Vliet, Darren Abbey, Simon Martin, Paul Martin before as well. I'm fairly new to the city as well, so the folks at the city that were helping to run this program, Dave Belanger, of course, and Scott Cousins over there. And then the folks that are in the field collecting the data that allows us to build a robust kind of field-based model. Beth Parker and the MG360 group at the University of Guelph, Abigail and the folks with the OGS. We saw all those great data sets presented earlier today. GRCA, Survey of Canada, the list goes on, but very much lots of partnerships related to this model, and I think it's stronger because of it. So I think this audience is familiar with the fact that the City of Guelph relies on groundwater for its municipal water supply. We pump about 50 to 55,000 meters cubed of water every single day, and we get that from 21 active supply wells. There's one shallow groundwater collector system at the Arkle Spring Grounds, and that's supplemented by a river intake and a recharge system to help boost the flow at that collector. So with the exception of that shallow collector, the primary source of this water is a bedrock aquifer here, which is this blue unit here, the Gasport Formation, which I think many of us are familiar with. It's Silurian dolostone. But you can see this is just a small cross-section. It's about 4 kilometers, kind of in the south end of the city. But this is just to show that even in a fairly small area, you can see that these units aren't kind of perfectly flat layer cake. There's a fair amount of variability in the thickness and distributions. You can see disconformities where some of these formations kind of pinch out, which are some of the main aquitard units. We've got corries and modern-day river valleys and sizing down into these units. We've got buried bedrock valleys. And so kind of spatially, it can be quite complex from a geological standpoint, but then also from a flow system, it can vary quite a bit across the region as well. So the challenge here from a municipality working on, trying to manage this resource and predict into the future, we really need to have a solid understanding of this 3-dimensional flow system and how this varies across the region. So this talk is going to focus on how we're using and how we've developed this groundwater model to help with this management. We'll go through a little bit of the history and the evolution of the model and then some steps into the future. So a quick slide here. The main point here is the fact that this has been an evolution. This model has been kind of over 25 years in the making. It started in the late 1990s as a mod flow model. We had a major improvement during some of the Tier 3 work where the bedrock portion of the model was improved significantly, which we'll see in the next few slides. And then I'll focus on kind of the most recent update, which is this Guelph groundwater model, what we're coining the Guelph groundwater model. So this is a snapshot of kind of the early days here. You can see very simplified flow system, consistent thickness in the models, continuous layers. It served its purpose at the time, but you can see things needed to evolve to capture a bit more of that, the heterogeneity, and to better reflect what's actually beneath the subsurface. And so as there was a big push during some of that Tier 3 time, kind of the 2008 to 2016 time period where there was lots of field data that was collected in the region from the actual Tier 3 boreholes that were installed that are these kind of golden spike locations where there was, a lot of these boreholes were continuously cored. There's high-resolution geophysics and multi-level wells. All of the stars on this map also represent the research sites at the Morwick G360 Institute where we had, again, this golden spike data. So there was a large amount of effort that went into capturing these high-resolution data sets to improve the model. And this is kind of the time period, again, where the focus was primarily on improving the bedrock aquifer, and you can see we're starting to capture a bit more of a realistic picture of what's happening in the subsurface. So you can start to see in those blue units, I don't think the laser pointer, it does kind of work. You can see we're starting to capture some of the reef mounds within the Gasport formations. You can see some of these regional aquitard units like the Vine Mount member, they start to pinch out, and we're starting to show some of this geological complexity. And then there was a lot of work on the actual hydraulic calibration using the various field data sets as well. And so this was, I think, the model that most people are familiar with. This is the Tier 3 model. This is what was used to develop the wellhead protection areas for quality and quantity for the city. If you look at the top of the model, though, you can see there are still some limitations. This is the overburden or the quaternary sediments. You can see it's very simplified, and it doesn't really capture the heterogeneity that we saw earlier in the session today within this region. And so in the last few years, we had a big model update, and Ashok Shah presented this last year at this meeting. So I'll just go over it fairly quickly. But there were three kind of key improvements to the model. One is to refine the geological conceptual model of the region using a leapfrog three-dimensional model, specifically focusing on the quaternary. We wanted to improve the estimates of groundwater surface water interaction as well as recharge within the model, and so there was a development of a fully integrated Mike Shee model, and then also just updating and recalibrating the entire Tier 3 model, after these updates to better reflect the current conditions, the modern day pumping conditions, which wells are offline and offline, more modern climate data as well. And so once again, we focused on trying to find these high quality golden spike locations, but for the quaternary this time. And you can see here, these stars now represent the Ontario Geological Survey golden spike. This is the regional drilling that was done by Abigail and others at the Ontario Geological Survey. The red dots are the Morwick G360 overburden or the quaternary boreholes as well. So lots of high quality data. So thanks to those that are collecting this. There was also quite a bit more, though that's kind of the highest quality data. We had reasonable coverage, but there's lots more data out there of varying degrees of quality. And so this slide was presented, I think, last year by Ashok, but this work was hard work by Ashok, who was doing a MyTax grant at the time, working with Emmanuel and the Montrose team. But he looked through 32,000 quaternary borehole logs of, ranging from these golden spike logs all the way down to, water well records. And to correlate that many borehole logs, there had to be some simplifications, and so they developed this sort of simplification or this lithology scheme where they could kind of group similar lithologies into a bit of a simplified structure here, this assigned lithology. So this is an example on, let me see. This is an example here. On the left is the high resolution, the nice lithology log from Abigail, and on the right, sorry. Let's go back here. So some of these units, like the clay and silt had to be combined. Sorry, Abigail, but to simplify this, and you can see that if you squint, you're seeing similar trends, but we did lose a little bit of the resolution, but it was necessary to compile this much data together. The next step was to assign hydrostratigraphy using kind of the OGS nomenclature. So looking at the list on the right there, that's the different hydrostratigraphic layers that have been identified in this area. And so to go through all these different logs and find the contacts of these different hydrogeologic units. So to give you a sense of the nature and the scale of this update, this is a view of the leapfrog model showing the bedrock. So we're kind of looking down towards the northeast. All of the sediments have been stripped away, so we're looking at the bedrock surface. And this is showing all of the quaternary boreholes that were integrated into the model or analyzed and correlated across the model domain. So these are the 32,000 boreholes. And then when we put the three-dimensional model on top, you can see how much more detail and how much more heterogeneity we're able to capture in the overburden. So it was quite a lot of work. And then this is a cross-section through the latest model. We're calling the Guelph groundwater model because it's evolved beyond this Tier 3 model now. But you can see, again, the bedrock is quite similar in terms of its representation, but now we have quite a bit more detail within these quaternary deposits. You can see the Periscald moraine off to the right and so on. So a fairly substantial improvement. So I mentioned before we use this model to define our wellhead protection areas and so on, but how else do we use this model kind of on a day-to-day basis to help manage this aquifer? So I've only been with the city for about a year, and I've pulled kind of the examples of how we've used this model within the past year to try and support our decisions moving forward. So this is an example where we use it to simulate long-term pumping from a proposed new supply well. So this is an example from our Northeast Water Supply Environmental Assessment Project. It's a new this is managed by Albany Douglas with the city, but this is a test well just on the outskirts of the city where we're assessing to become a future supply well for the city. It's undergoing an environmental assessment right now. Part of that involved a 30-day pumping test with extensive monitoring, field monitoring around this well. This data was then given to the Montrose team where they recalibrated the model using this data, and then we could then use that model to predict, into the future, 5, 10, 20, 50 years to see what the long-term implications of pumping this location may be on, other wells in the area, surface water bodies, or creek-based flows, and so on. Another use is to assess potential impacts from private water takings. So as a municipality, dependent on groundwater, we often keep our eyes and ears open for permit to take water applications that we think may have an impact on our water supply. And so this is an example of two nearby quarries, the Glen Christie and the Wellington quarry, just to the southwest of the city here, kind of between Guelph and Cambridge. And they had two active permit to take water applications for dewatering. And so we had our team at Montrose simulate, these proposed water takings, different rates and different extents of the quarries to see if it may have an impact on our water supply. And this is an example output from that showing this is kind of the worst case scenario with both quarries pumping at the same time at their proposed fully permitted rates. And the contours here represent drawdown within the Gasport Formation, so our main supply aquifer. And you can see that, the extent of that drawdown extends quite far beyond those quarries, well into the city of Guelph, across almost the full city. And then the table on the right shows the various wells that have kind of an estimated measurable impact, reduced flow from that dewatering. And so you can look at the full list here, but I mean, the main take-home point here is that it has the potential to reduce our production by about 1,266 meters cubed per day, which translates to the water that would be required to service almost 8,000 people in the city. So at a time when we're trying to find new water sources to meet a growing demand, we're concerned about potential impacts like this. So we can use this type of output from the model to have an informed response to the ministry or to help try and find, mitigation methods such as re-injecting this water to try and mitigate some of these impacts. Finally, we've been getting more involved in kind of the development reviews at the city. So anytime we see any sort of permanent dewatering proposed within the city boundaries, once again, we're not a big fan of that. So generally, the city strongly discourages permanent dewatering. But we do have this tool now. So if a developer really wants to pursue this for, say, underground parking or so on, we can talk to them about, trying to coordinate the use of the model to try and assess what impact that may have on the city's supply. And finally, that nice three-dimensional leapfrog model is a really amazing way to now interact with the model to see what the geology is like beneath our feet. And so this is something that I use on a regular basis now that we have this available to us, where we can just kind of fly around the aquifer, we can generate cross sections, we can look to see if there's a development going up, just quickly, what's the expected depth of bedrock, what kind of geology and formations do we have beneath that development. So it's just a very handy tool to see, to interact with the model. So some future work, there's always data gaps. We still have data gaps within this model. It's a very large domain, so we're looking to try to fill some of these gaps moving forward into the future. We have another active MyTax project with Ashok and Emmanuel and Beth Parker, looking at improving the representation of the bedrock and quaternary interface, how well those are connected and the hydraulic connections between those. Eventually, once we bring on some more water supplies, if these wells eventually do become new sources, we will likely have to redo our wellhead protection areas, so we'll be using the model for that. And we're also working on ways to try and manage this aquifer and manage the model and share the model so it's more readily available to the folks in this room or those who might be interested in working with that. And we're having conversations with Steve at the Oak Ridges Moraine and trying to assess how we're going to approach that. So your question might be, can I use it? And then my answer is kind of almost. We are working on this. We would like to make this more available to folks. So certainly, the geological model and Leapfrog and the Tier 3 model. But yeah, stay tuned for progress on that front. And that's all I had for today. So thanks very much for your attention.